This video in the Pure Maths 1 course is the first of two videos on arithmetic series. This one deals in fact with arithmetic sequences. A sequence is a list of numbers. For example, 1, 3, 5, 7, 9 and 11. This is a sequence of odd numbers between 1 and 11. Not to be confused with a series which is a sum of a sequence of numbers. For example, 1 plus 3 plus 5 plus 7 plus 9 plus 11. Another sequence could be the list of square numbers between 1 and 100. For example, 1, 4, 9 up to 100. Now, if we don't want to write the whole list of numbers, we can write the first few. Like here I've got the first 3, so we can see how the sequence goes. There are square numbers, and then 3 dots, which means carry on in the same way, and then the last one in this case is 100. So 1 squared, 2 squared, 3 squared, and we carry on until we get to 10 squared. The notation for the terms of a sequence, each number in the sequence is a term. We would write u, n, in this case is n squared. So we'd have u1 is 1 squared, u2 is 2 squared, which is of course 4, u3 equals 3 squared, which of course is 9, etc. up to u10, which is 10 squared. For the odd numbers, we could write 1 to 11. We could write un equals 2n minus 1. We double any number, we get an even number. We take away 1, we'll get all the odd numbers. Now this is an example of an arithmetic sequence. In an arithmetic sequence, each term is the same amount. There is a common difference between each term. So in this case, to get from 1 to 3, you add 2. From 3 to 5, we add 2 again. From 5 to 7, add 2. And add 2 each time to get the next term. In this sequence here, minus 5, minus 1, 3, 7, 11, 15, 19, the common difference is 4. We add 4 each time to get the next term. In this sequence here, we can see the terms decrease. Start with 19, 14, 9, 4, minus 1, minus 6. Well, we're subtracting 5 from each term to get the next one, so we say the common difference is minus 5. In an arithmetic sequence, we always call the first term a, and the common difference is d. So the first term, which is u1, equals a. Then u2, we add d, so we have a plus d. u3, we add d again, so it's a plus d plus another d, so a plus 2d. u4 then is a plus 2d and another d, which is 3d, and so on. So u5 is a plus 4d. We can see a pattern here. u3 a plus 2d, u4 a plus 3d, u5 a plus 4d. It's each term would be a plus and 1 less than the term number times d. So in other words, we could write the nth term, un, is equal to a plus, and it will be n minus 1d, because the multiplier of d is always 1 less than the term. And this is our formula for the nth term which we need to know and we'll be using. Here are some three examples of how we might use this formula. Here's the first one. Find the 15th term of the series 3, 5, 7, 9, and then it carries on. So we put the 3 dots there to signify that we carry on in the same way. Right, well, this is an arithmetic sequence. We can see that to get from one term to the next, we're always adding 2. It's the odd numbers starting at 3. The first term is A. The first term A is 3, and the common difference D is equal to 2. So U15, using the formula, is A, 3, plus n minus 1, that's 15 minus 1, times D, which is 2. And that is 15 minus 1 is 14, times 2 is 28, plus 3, 31. So the 15th term is 31. Example 2, find the number of terms of this series, 4, 11, 18, 25, and it continues up until 144, but we want to find how many numbers are in that sequence. Well, using the formula again, un is a plus n minus 1 d. Well, we know that 144 is the nth term, where n is the number of terms. So we can put 144 here equals a, and that's 4, plus n minus 1 times a common difference, and we can see we add 7 each time to get the next term. 4 plus 7, 11, plus 7, 18, plus 7, 25. So 144 is 4 plus 7n minus 7, or 7n minus 3, and then solving this simple linear equation, adding 3 to both sides. 147 is 7n, dividing by 7, n is 21. So 21 terms in the sequence. The third example is this one. Determine the first term of 12, 19, 26, 33, and so on, which is greater than 1,000. So we often get examples or questions which involve inequalities. We want to know here, if we continue this sequence, which is the first one which is greater than 1,000. So using the formula again, un is a plus n minus 1d. We want to know the value of the term, which term is greater than 1,000. The first term, a, is 12. The common difference, d, is 7. So we want un to be greater than 1,000, or a, 12 plus n minus 1 times d, 7, must be greater than 1,000. 12 plus 7n minus 7 must be greater than 1,000. That is 12 minus 7, which is 5. We put onto the other side, subtract from both sides, we have 7n greater than 995. Divide by 7, n must be greater than 142.14. So n, as it is a whole number, an integer, the first number greater than 142.14 is 143. So the term, a first term greater than 1,000, is the 143rd term. U143 would be a, which is 12, plus n minus 1, 143 minus 1, times 7, 142 times 7, and that comes to 1,006. So that's the first term greater than 1,000. Now return to Study Smart and watch the next video on arithmetic series, second video, which is about the sum of an arithmetic sequence, which is an arithmetic series.